show that limit x tends to 2 minus mod x minus 2 by x minus 2 is equals to minus 1. To solve this problem, we remember the definition of modulus function. We know mod x is equals to x if x greater than equals to 0, and it is equals to minus x if x less than 0. This is the definition what we learn in lower classes. This is the modulus of a function. Similarly, for the given problem, we have mod x minus 2 is equals to x minus 2 if x greater than or equals to 2. And this modulus is always is equals to minus of x minus 2 if x less than 2. Okay. So mod x minus 2 is equals to x minus 2 if x greater than equals to 2 is equals to minus of x minus 2 if x less than 2. Here x greater than equals to 2 can also be written as x approaches to or x tends to 2 plus. X less than 2 means x tends to 2 minus. Okay, given problem involves x tends to 2 minus. So here modulus of x minus 2 can be taken as minus of x minus 2 by the definition of here by x minus 2. So x minus 2 cancelled. We have a minus 1 by 1, that is equals to minus 1. Now compute a limit x tends to 2 plus square bracket x plus x and limit x tends to 2 minus square bracket x plus x. So we need to compute here x tends to 2 plus this limit and x tends to 2 minus this limit. Here square bracket denotes the integral part. So to solve this problem we need to know about integral part of x. Here square bracket x is the greatest integer which is less than or equals to x. This is the definition of integral part of x. So integral part of x is the greatest integer which is less than or equals to the given value x. Okay. So for example, integral part of 2.3. We know integral part of 2.3 in the above note we have x, like as above definition it is equals to 2 only because the nearest integer value for 2.3 is 2. Another example is integral part of 2.6 is equals to 2 also. Okay. Now the given problem involves two conditions. X tends to 2 plus. That's why 2 plus means after 2 means about 2 values which are near to 2. Okay. That means x tends to 2.1, 2.01, 2.001. So it approaches to 3. Okay. X tends to 2 plus means greater than 2 values and approaches to 3. That is the meaning of x approaches or x tends to 2 plus. Okay. So this can be written as closed bracket 2 comma 3. So for all values of x in closed interval 2 comma 3 is the value of is the value of x, means integral part of x, which is less than or equals to x value. Here x value is 2. Okay. So this is the value if x tends to 2 plus by the definition of integral part. Now the another condition is x tends to 2 minus. X tends to 2 minus means x approaches to less than 2 values. Sorry, here minus 2 plus, minus 2 minus. So here also, yes, minus 2 minus or minus 2 plus. Okay. X tends to minus 2 plus means minus 2 plus means x values greater than minus 2 values. So greater than minus 2 values means yes, minus 1.9, minus 1.99, minus 1.999 and so on. So greater than minus 2 values, that means. So for any values of these, values, integral part of these values or integral part of these x values is always equals to integral part of these values is always equals to minus 2, because the greatest integral integer value which is less than or equals to the given values here. So it is obviously minus 2. Okay. Now x tends to minus 2 plus is over. Now we compute this limit by using this information. Limit x tends to minus 2 plus square bracket x plus x is equals to, so x tends to minus 2 plus means the integral value is minus 2. Okay, in this case square bracket we put x tends to 2 minus 2 plus integral part of x is clearly minus 2 plus minus 2. Okay. Now in this case integral part of minus 2 is always minus 2. That's why minus 2 plus minus 2 equals to minus 4. So limit x tends to minus 2 plus square bracket x plus x means integral part of x plus x is equals to minus 4. The other part is also there, that is limit x tends to minus 2 minus integral part of x plus x is here x tends to minus 2 minus means x tends to minus 2 minus means x values approaches to less than minus 2 values. So what are the less than minus 2 values? Minus 3, minus 4, minus 5, like this. Okay. So that's why I am going to write x values as minus 2.01, minus 2.001 and so on, because we take all values of minus 2 which is near to minus 2 values and less than minus 2 values here. Okay. That's why for all values of here, the integral part of these values, is clearly integral part of these values is means, what is the integral part of these values? Is the greatest integer which is less than or equal to the given values here. Okay, minus 2.01, minus 2.001 and so on is the smallest. What is the smallest integer of the given values of here is clearly minus 2 is the smallest integer is here in this interval, in this values, the smallest integer is minus 3 because minus 2 is greater than minus 3. The integral part of any x is the smallest integer of the given number. That's why here the smallest integer value is minus 3. Now limit x tends to minus 2 minus integral part of x plus x is equals to integral part of minus 2 plus minus 2. Integral part of minus 2 in this case, minus 2 minus case is minus 3 plus minus 2. That is equals to minus 5. This is the second part. Okay. Now compute limit x tends to 0, a power x minus 1 by b power x minus 1. Here a greater than 0, b greater than 0, b not equals to 1. To solve this, we remember the standard limit formula. Limit x tends to 0, a power x minus 1 by x is equals to log a. So to convert this problem into this formula form, we divide numerator and denominator with x. So a power x minus 1 by x by b power x minus 1 by x. Now limit can be applied both numerator and denominator. That is limit x tends to 0, a power x minus 1 by x. Limit x tends to 0, b power x minus 1 by x. Okay, because we have the algebra on limits. Limit x tends to a, f of x by g of x is equals to limit x tends to f of x by limit x tends to g of x. The given function in p by q form. So limit can be applied for both numerator and denominator. So for numerator value we have the identity like this. So it is equals to log a by the denominator value is also compared this identity. It is also equals to log b. So log a by log b is equals to log ab. Now compute limit x tends to 0, e power x minus sin x minus 1 by x. So to solve this limit, we put e power x minus 1 at one place or together. So limit x tends to 0, e power x minus 1 by x minus limit x tends to 0 sin x by x. We have the identity value 1 minus 1 equals to 0. Compute limit x tends to 0, e power 3 plus x minus e power 3 by x. So to solve this, put e power 3 as common. So limit x tends to 0, e power 3 of e power x minus 1 by x. Now here e power 3 is constant taken at outside. Limit can be applied only for x values here. Limit x tends to 0, e power x minus 1 by x. Because limit x tends to a, k into f of x, constant multiple rule. K limit x tends to a, f of x. Okay, e power 3 into the total of this limit value is equals to 1. So it is equals to e power 3. Now compute limit x tends to 0, e power 4x minus 1 by x. So limit x tends to 0, e power 4x minus 1 by x. To convert this problem into the standard form of the limit, multiply and divide with 4. So 4 into limit x tends to 0 e power 4x minus 1 by 4x. So 4 into, this is on the standard form of 1 is equals to 4. So now compute limit x tends to 0 e power 2 plus x, e power 2 plus x. Like as this problem, we can solve this problem easily. Now compute limit x tends to 5 e power x minus e power 5 by x minus 5. Solution. The given problem, limit x tends to 5 e power x minus e power 5 by x minus 5. So limit x tends to 5, so e power 5 taken it to common, e power 5 of e power x by e power 5 minus 1 by x minus 5. So limit x tends to 5, so e power 5 is constant, taken it to outside of the limit, e power 5 into limit x tends to 5, e power x minus 5, which is of the form a power m by a power n. So e power x minus 5 minus 1 by x minus 5 is equals to e power 5, because to compute this limit, we depend upon substitution method. Put x minus 5 equals to y. From that x value is y plus 5. Now change the limit x values into y values. If x approaches to 5, then y approaches to 0. Now the above limit can be totally transformed into y variable. That is limit y tends to 0 e power y minus 1 by y. E power 5 into this limit is in standard form, that is equals to 1. So e power 5 into 1 equals to e power 5. Now compute limit x tends to 3. This problem can also be solved with this like this. Okay. Now compute limit x tends to 0 e power sin x minus 1 by x. So to solve this limit, by using this identity, limit x tends to 0 e power x minus 1 by x is equals to 1. So, and other standard form, limit x tends to 0 sin x by x is equals to minus 1. So here numerator value is, divide this numerator value and denominator value with sin x. So e power x minus 1 by sin x by x by sin x. So limit x tends to 0, the numerator value is e power sin x minus 1 by sin x into the reciprocal of this denominator value, that is limit x tends to 0 sin x by x. So the first limit is in standard form and the second limit is also in standard form. 1 into 1 equals to 1. Okay. Now compute limit x tends to 0 x into e power x minus 1 by 1 minus cos x. So if we put x is equal to 0 in this function, it is of the 0 by 0 form, indeterminate form. That's why we can transform this function into, we can simplify this function. So x of divide the numerator and denominator with x. So x into e power x minus 1 by x by 1 minus cos x by x is equals to limit x tends to 0 e power x minus 1 by x into limit x tends to 0, the reciprocal of the denominator value, x into x is x square by 1 minus cos x. The first limit value is totally equals to identity, that is equal to 1 into, here we have the formula cos 2a in sine, that is 1 minus 2 sine square a. If we put a equals to a by 2 in the above identity here, then cos a equals to 2 cancel, cos 2 into a by 2 means 2 to cancel. Cos a equals to 1 minus 2 sin square a by 2. Okay. So from this 2 sin square a by 2 is equals to 2 sin square a by 2 is equals to 1 minus cos a. 1 minus cos a. So use this in the limit here. Limit extends to 0, x square by 1 minus cos x means 1 minus cos a form equals to 2 sin square x by 2. Okay. So here 1 by 2 is constant, taking it outside. 1 by 2 into limit extends to 0. Now divide numerator and denominator with the x square like this. So x square cancelled out. The numerator value is 1. 1 by 2 limit extends to 0. 1 by sin square x by 2 by x square. 1 by 2 limit extends to 0. 1 by sin square x by 2. Now multiply and divide with 2, not 2 here. One by 2 into, yes, 1 by 2. So here multiply and divide with 4. Yes. So that is equals to 1 by 4 also here. 1 by 2 limit extends to 0. So reciprocal of 1 by 2 is 4 by 1. This is completely an identity form, that is 2 into 1 equals to 2. Compute limit extends to 0, log of 1 plus 2x by x. So to solve this limit, multiply and divide with 2. Okay. So limit extends to 0 means 2x tends to 0 also. Log 1 plus 2x by 2x into 2. So 2 is common, taken it to outside. 2 into this limit extends to 0, log of 1 plus x by x form. It is equals to 1. 2 into 1 equals to 2. Compute limit extends to 0, log of 1 plus x cube by sin cube x. So to solve this, divide numerator and denominator with the x cube like this. Now apply limit to numerator and denominator. Limit extends to 0, log of 1 plus x cube by x cube by limit extends to 0, sin cube x by x cube can be written as sin x by x whole cube. Now the numerator value is totally in the standard form, that is 1, and denominator value is also in standard